In the figure shown, triangle ABC is inscribed in the circle. What is the circumference of the circle? So circumference is equal to 2 pi r. So I think this is, what is 2 pi r? So we need the radius, but they don't really give us any more information. So got to look at the statements. AB is a diameter of the circle. So I was sort of expecting something like this because there is a rule. And rather than write it out, I will type it out. And this rule says that I'll write it first and then we can talk about it. If you have a triangle inscribed in a circle and one of its sides, and it will be the hypotenuse, is the diameter of the circle, and the triangle is a right triangle, and vice versa. So if you have a triangle that is inscribed in a circle and it is a right triangle, then one of its sides, the hypotenuse, must be the diameter of the circle. So this is a rule that is just worth memorizing because it does come up, and usually when it does come up, sort of like if you know it, the question's easy. If you don't know it, and then you got to derive the rule in the middle of your test. So in our case, if they are telling us that AB is a diameter of our circle, then this means that we have a right triangle. We don't know anything about the length, though, necessarily, so by itself, it's still going to be insufficient. Statement 2 says the ratio of the lengths of BC, AC, and AB, respectively, is 3 to 4 to 5. So we have this ratio of 3 to 4 to 5, now 3 to 4 to 5. So we know Pythagorean theorem says a squared plus b squared is equal to c squared, but this should only work when we have right triangles. And so in this case, I know 3, 4, 5 is sort of a special triangle, a special type of right triangle that people will just tell you to memorize. But if you don't know that, you can still prove it because 3 squared plus 4 squared is equal to 5 squared, because 9 plus 16 is equal to 25. And so if you have a triangle and the sides can be plugged into your Pythagorean theorem, one of the things that's telling you is that that triangle must be a right triangle. So statement 2 is it's telling us the same thing as statement 1, that we have a right triangle, but now here we know the values for our sides. However, this just says the ratio of the lengths of our sides. So it could literally be 3, 4, and 5, but it could also be 6, 8, and 10. So based on that, we're not going to be able to find our circumference together. So now sort of together, they're not helpful because they just, all of the information we know from statement 1 is also contained within statement 2. So nothing is really added. So just knowing we have a ratio isn't helpful, and we don't really have any values or anything. So even though we got to use our rule and a Pythagorean theorem, it doesn't really get us anywhere. So E.